Hello, good evening, and welcome to the last talk of the first day of KubeCon London 2025. I'm Jason Braganza. I serve as an independent consultant to small and medium businesses in Bombay, India.
Hi everyone, my name is Priyanka Saggu. I work at SUSE as a Kubernetes integration engineer, and I'm also part of the Kubernetes upstream project. I'm one of the technical leads for Kubernetes SIG contributor experience.
So we're talking today about learning Kubernetes through the lens of metrics. It's all about what we learned about Kubernetes through the various as we go about learning stuff. Like this talk is a spiritual kin to our last talk on KEPS, where we spoke about what we learned about Kubernetes while going through the Kubernetes enhancement process documents. You can find the recording here. Most of the footnotes and the links that we talk about, if we say they're online, you can find them in a little thing there. So like I said, this is a new lens on learning Kubernetes and the stuff we learned tinkering with Kubernetes clusters. What this talk is not is a guide to metrics or to writing metrics efficiently. It's more about what we grokked exploring metrics. So what it is about the interesting things we learned and the path of discovery we took to get there. So let's begin. Did you know that Kubernetes metrics can tell you which features are enabled in your cluster with alpha or beta or stable, or reveal how many pods a kubelet is running, how many are waiting to be scheduled, how much byte space container logs consume in your cluster. They can even track mirror pods, live goroutines, or the latest HCD compaction revision. So these seemingly small data points hold huge insights, and that's just scratching the surface. Here's the thing, there's too many metrics out there in the world, in the cube world, and there's no good A to Z guide to go through them. So all of this is basically the stuff that we found. We're using the anecdotes themselves as guides, and we'll walk through a few interesting metrics and the lessons we learned. So the structure of a metric itself, as exposed by Kubernetes, looks a little something like this. There's obviously the name, as we've seen, but then it also, we've kind of decomposed it into these 4 sections. The first one is the help section, which gives us the definition of the metric when you look at it. There's the type of the metric. There are various types, like you see there's gauge or counter or summary, histogram or untyped. So, I don't really want to go into all of these because that will take too long. These talks helped us a lot learning about the kinds of metrics. While this gives us a good primer, this talk gives a good primer on all the sorts of metrics that are out there. And this little one explains histograms in greater detail. The next section is the stage of the metric. The metric itself in the Kubernetes world has a stage. It goes through alpha, beta, stable, deprecated, or if a metric is no longer hidden as gets deprecated, it then gets hidden and then deleted. It's explained in great detail on the website. We can find details down in the link below. And the fourth part is the metric itself, like the values of what the metric there, along with the optional labels in there. Here's an example with all our sections highlighted. We have the name, it's Kubernetes build info. The help gives us the definition. It's a metric with constant one value labeled by major, minor, git version, git commit, git restate, and a lot of additional data. What it gives us is basically an insight into what version of Kubernetes we're running, what Git version it was built on, what Go version was used to compile it, the major and minor versions, and the platform. So let's now look back at our anecdotes, and I'll hand it over to Priyanka to take us from here.
So, like Jason mentioned, there is no A to Z good guide to go through all the Kubernetes metrics, and I can say in last month itself, when I started to learn and go through the Kubernetes metrics, I found there are hundreds and hundreds, and it could be thousands also. So what we are going to do today is all the anecdotes we started with, we are going to use them, not all, but at least few, and we'll see what we learned out of those metrics. The first thing we pitched as part of this talk was which Kubernetes metrics can tell us which features are enabled in my Kubernetes cluster. So let's use a small kind cluster and see what all is there. And here I am creating a kind cluster. I'm just checking if my cluster is ready. And kind by the name, it's Kubernetes in Docker. So let's try to find out what is the name of the Docker container where my kind control plane is running. That's what I'm doing in the first command. And exec inside the container. Yeah, Docker container. So once I am inside the Docker container, the first thing I would do is check where my, get some information about my cluster. So kubectl cluster info is giving me that information. And one of the information it is giving me is where my API server or control plane is running. Since API server is the most prominent component which actually makes the Kubernetes cluster a Kubernetes cluster, let's try to see what kind of metrics is exposed by that. And we can already see here where would I find the metrics exposed by Kubernetes API server. So that would be https:// control plane at 6443 port. I also have left a note. Kind control plane is just a mapping to local host on this Docker container. So let's use local host so that we can follow along with the next set of examples here. Another thing I'm also doing is, for me to access the metrics, I can't just do curl commands, just randomly curl commands. I have to authenticate myself. So this is the reason why I exec inside the Docker container, because the Docker container is serving as a control plane host. So control plane host contains my certificates and keys. So I'm using the certificate and keys here to make my curl request and hitting the local host 6443 at the metrics endpoint. And what I get is something like this. I can't take the screenshot of the entire metrics that I'm receiving from here. So this is just a portion, but we are interested in this particular metrics. So API server exposes this metric called Kubernetes feature enabled, and this is the metrics that provide us information about what all features are enabled on my kind cluster we just created using kind create cluster. And what I can see here is the help and type that Jason showed us. So I can just read the help and it's telling me this metric records the data about the stage and enablement of a Kubernetes cluster. So by enablement, if I'm seeing 1 in front of any metric data point, that means that is enabled. And wherever I'm seeing a 0, that means those features are available, but they are not really enabled or in use on my Kubernetes cluster. These are single data points, but if I want to make use of this metrics, which most people who are into monitoring and observability, they would be aware about Prometheus, Grafana, or other monitoring applications. So here I'm just using a simple Helm chart for the Prometheus stack. These are the commands. I'm trying to install Prometheus on my tiny kind cluster and just port forwarding so I can access the Prometheus dashboard. And here, when I ask Prometheus to give me all data points of Kubernetes feature enabled, this is what I'm getting. And here I can use Prometheus queries to do some more statistics. So here I can count how many features are enabled on my kind cluster. This one is giving me the one in just empty brackets. I understand them as stable because once any feature is stable, they don't really have a stage. And the other ones, I can see how about 94 features on my kind cluster are available, which are in alpha stage right now, 158 beta, and 8 deprecated as well. I can also do some more queries here. So these are just all the enabled ones. And if I change the query to 0, these are all the disabled ones. So these kind of information I was able to get from just one metric itself. And I was really impressed by it because, wow, a metric is just telling me how many features are available on my tiny kind cluster. Next up, we talked about how many pods a kubelet is running. This one is very, very basic because we see a lot of talks at KubeCon about how many we are scaling our cluster to thousands and I don't know, millions of pods and containers, et cetera, et cetera. This is all tracked by metrics and metrics like these. So let's see which metrics now we can try to pull out from where we can get information about how many pods or containers are running on our kubelet. So we saw 6443 was API server, but I want to see what all other components are running on my Docker control plane host. So I just tried to look for all the components here, and I found 10250 is running kubelet here. So let's try to hit kubelet in the next slide. But I also wanted to give a shout out to this blog post. The link is below. This also helped me a lot to find out a lot of different metrics exposed by many different components from the Kubernetes one. I think I started by kubelet, so we are talking about this one here. So I figured out kubelet is running on 10250, so I'm doing the same thing this time, but hitting a call request on 10250 metrics endpoint. And I get metrics like this. One of the metrics here is kubelet node name. And it's just giving me, since this is a kind cluster with just one node name, I can see kind control plane is the only node available here. And I can now start seeing more information. How many desired pods are supposed to be there or are supposed to be running on this kind cluster. So 11 are supposed to be running, well, 11 and 4. So we get 11 and 4 here. And if I want to now understand why 11 and 4 are coming, I can go back and read the help. And help says the number of pods that kubelet is being instructed to run. Static is true if the pod is not from the API server. So this is not only giving me the entire number of pods that should be running on kubelet, but also categorizing them, how many API servers should be running, and how many kubelet directly should be running. The static ones are directly taken care by kubelet. So the one which has static true are basically handled by kubelet itself, and 11 are created by API server. And we can see now number of mirror pods, which is equivalent to kubelet created 4 static pods. Now API server have to maintain a copy of them. So we also see that information here. So I'm seeing a lot of information about the pods and containers running on my machine. I can also try to see the same kind of information in Prometheus using the same metrics. So kube pod info is giving me a lot of information with a lot of labels now, which I can then try to query. And like this simple query is just giving me how many pods are how many total number of pods are running on my kind control plane node. And which answers our question, how many pods or containers are running on our node. Next up, kubelet not only just gives us kubelet stuff, but there is another endpoint which is exposed by kubelet called CAdvisor, and that can give us information like this. I can find out information about the kernel version or OS version on my host using metrics like CAdvisor version info. And this one was very interesting to me, container memory kernel usage. I wanted to see how this metric is receiving the value that I see here in the red, how this value is coming up. So I actually tried to dig a lot and explained it here. How did I come up with how did that value is coming up, how I'm able to get the kernel memory usage statistics. And it was really nice. It wasn't too difficult. Yeah, and I explained the process here. Then this next one was very simple, but really made me smile. It reminded me of the WhatsApp last scene. So there is a container last scene metrics as well, which tells us every time the container was last seen. And I can see here all of these containers last seen are listed on the right-hand side. And Jason earlier mentioned the Kubernetes metrics moves through many different cycles. So they start from alpha, then go to beta, then stable. And if once they are stable, either they stay or they can be marked as deprecated. And if they are marked as deprecated over time, if they are useless, they can be made hidden. Hidden means that Prometheus will no longer be scraping them, or they can be deleted as well. So if any of them is marked as hidden, we can also get those hidden metrics information. So I realized, okay, there is a metrics called hidden metrics total, which is telling me in my kind cluster, which I just created for fun, also have 2 hidden metrics available. And there's a whole documentation about how to check these hidden metrics, or how we can start seeing these hidden metrics as well on the kubernetes.io documentation here. There are a lot of links here, so we have tried to have this slide deck in a way that if somebody uses our handout notes, they can try to copy paste the commands and run them as well. And then we have some grab bags, because I don't want to go through each of the components. So if you are interested in, for example, getting network or firewall related data, you can again check for the kube API, kube proxy port. In this case, it's 10249. This time we are hitting localhost 10249 metrics, and I can get information like total number of IP tables rule owned by kube proxy. And not only that, labeled by different IP tables like filter, NAT. So in this case, I can see there are 3 IP tables under filter, and then 5 under NAT. Or other things like how many packets are dropped by IP table to work around this contract problems. I was very interested in this one. So what I did was I copy pasted this metrics and tried to find out why this matrix was added in the first place. And what I did, I actually should have included a slide, but I can explain what I did. I tried to go on this Kubernetes/Kubernetes GitHub repo and searched for this metric name. I got some code path, and then I eventually ended up at the PR that added that metric. And I realized like somebody was somebody was having some problem with contract, and they wanted to now track how many packets were getting dropped because of those problems. So they decided to add metrics. Now, why we are giving this talk and why we are discussing so many metrics, because whenever I was whenever I was seeing new and new metrics, I was learning about components within my cluster that I would not really like think about. So it was increasing my knowledge of how my tiny Kubernetes cluster was working on, how many data it was holding, and how I can learn about Kubernetes in general just by reading these metrics. And if I find something interesting, I can go and find more details about that. So I'll skip kube proxy. There are more things we can find here. I'll move to this one. How many pods are waiting to be scheduled? So this was also one of the things we discussed, we talked about in the very early of our talk. So scheduler gives us this information. And when I saw this metrics, that was the first time I realized scheduler maintains different queues. So I thought like, okay, I'm applying a pod and it will just wait, and at some point it will be scheduled. But no, there are different categories how scheduler is putting my pod into an active queue or a backoff queue, and gated and unschedulable, etc. This was the first time I learned about these queues. So if anyone is interested, they can also go and find out scheduler pending pods and learn about these queues like I am going to do. And not just that, we also talked about something etcd related operation. Like etcd is the key value store that Kubernetes uses to put everything, the entire state of the Kubernetes cluster. And there is a lot that goes into maintaining that information, because if we are talking about a production Kubernetes cluster, we are storing data, millions of lines of data every single hour. And we can't keep all that data. So there are things like compaction happening to make sure our key value store does not just blast off. So we can also like try to find out information about that here. Again, from the earlier commands, I figured out 2379 is where etcd is running, and I'm trying to hit etcd metrics point here, and these are the information I can try. I can get from etcd metrics, like etcd cluster version. Etcd have two versions. Right now we get etcd version 3, so I can get that information, or at least verify if I'm using etcd version 3 or the known 3, and use my etcd-ctl commands accordingly. Or things like the total number of granted leases, or the total number of renewed leases. So if somebody is aware of etcd and how etcd works, you can get like information about leases as well from etcd. How many are revoked? So all these information is given by etcd as well. And this is what I was talking about, the MVCC compaction revision. Every time we have a lot of data stored in etcd, and we have to keep storing more, we have to run compaction so that whatever data is no longer in use, or we have many revisions, we can like run some compaction. So this is giving me the last compaction where it's some revision, some last revision number where some compaction has happened, and the current revision of store. So I'm getting all those information. And not only that, how many keys were actually compacted. So this is going into details of etcd here. And things like what Go version is my etcd using. So I can, like, this one is an older kind cluster, so I can see the etcd component in my kind cluster is using Go 1.21 and the patch 12. So things like that I can see from just from the metrics. And one more thing, we also touched upon how many OS threads are running in my kind cluster. So I can also get those counters as well here. So there were a lot of metrics here. We wanted to add more, but there was just no way we could have added everything here. So we tried to at least add things that I found super interesting, or that invoked my wishes, my interest into learning more and more about it. And we tried to add them here. If you have more such scenarios where you want to use metrics to learn more about the Kubernetes cluster, I would like highly recommend going back to the slides and find out the footer notes and use those links to play around with metrics yourself. And with that, we did not really had a wrap-up slide, so we'll just end up with our contact information. If you want to talk to us about the previous talk we did about KEPS, or this one, you can find us on slack.creators.io. This is the Kubernetes Slack. Our handles are Saggu, Jason Braganza, or you can write to us at our email address. And with that, I'll stop, and thank you for attending. I'm open to questions if anyone is interested.